The K2-18b breakthrough, the James Webb Space Telescope, or JWST, is regarded as humanity's most powerful scientific tool for exploring the depths of space. It is not merely a telescope, it is a revolutionary instrument designed to transform how we see the universe. Its mission stretches far beyond gazing at distant stars. It aims to investigate the mysteries of our solar system. It studies planets that orbit faraway stars, known as exoplanets. It observes the vast cosmic structures that shape galaxies and bind the universe together. It even challenges us to reconsider humanity's role within the grand design of the cosmos. Recently, scientists pointed JWST's extraordinary vision toward a star system about 120 light-years away from Earth. What the telescope revealed astonished the scientific community. It uncovered convincing evidence of carbon-based compounds within the atmosphere of a distant world. This world is thought to be covered, at least in part, by a vast liquid ocean. Such a discovery has triggered exciting new discussions about whether life-supporting conditions could exist elsewhere in the universe. Join us as we explore this groundbreaking revelation. We will examine what it tells us about alien worlds and their potential for habitability. And if you are eager to stay informed about the latest scientific and astronomical breakthroughs, remember to subscribe, like, share, and activate notifications so you never miss our future content. NASA's James Webb Telescope has now reached a critical milestone in its study of the exoplanet K2-18b. This planet is a giant world, about 8.6 times more massive than Earth. The reason this discovery is so important lies in the detection of key carbon-containing gases. Scientists confirmed the presence of both methane and carbon dioxide within the planet's thick atmosphere. These findings give strong support to earlier theories that K2-18b might host conditions suitable for life. K2-18b orbits a red dwarf star called K2-18, located in the Leo constellation. Even more importantly, the planet lies within its star's habitable zone, the region where liquid water could exist. This raises the possibility that beneath its hydrogen-rich skies, the planet might hide a global ocean. Such worlds, sometimes referred to as sub-Neptunes, are especially intriguing because they are absent in our own solar system. On Earth, oceans are central to the emergence and survival of life, making K2-18b a fascinating subject of study. Adding to the intrigue, scientists detected hints of dimethyl sulfide, a chemical on Earth primarily produced by microscopic plankton in the oceans. While the evidence remains tentative, future JWST missions will search for more proof of this compound. If confirmed, it could be a powerful sign of biological activity. However, researchers caution against leaping to conclusions. K2-18b is significantly larger than Earth, about 2.6 times Earth's diameter. It may be cloaked in thick icy layers buried beneath its outer atmosphere. Even if enormous oceans do exist, they could be under extreme pressure or filled with chemicals hostile to life. Despite these uncertainties, the discovery is monumental. It provides scientists with the most accurate atmospheric model ever built for a sub-Neptune planet in a habitable zone. This is a significant leap forward in the ongoing search for worlds capable of supporting the wider cosmic impact of JWST. The incredible discovery of K2-18b was only the beginning. This success was achieved through an advanced technique called transit spectroscopy. K2-18b is known as a transiting exoplanet. This means that, from our perspective on Earth, it passes directly in front of its star during orbit. When this happens, the starlight we receive is not pure. Instead, a fraction of that light is filtered through the planet's atmosphere before it reaches our telescopes. This thin layer of light is invaluable. It carries chemical fingerprints, tiny imprints of the gases and compounds present in the planet's skies. With JWST's extraordinary sensitivity, astronomers are able to read those fingerprints like words on an ancient scroll. It was through this process that methane, carbon dioxide, and even hints of dimethyl sulfide were uncovered. No other instrument on Earth or in space has ever been able to provide this level of clarity. Future missions will use JWST's mid-infrared capabilities to go even deeper. By observing K218b at longer wavelengths of light, scientists will be able to reconstruct the planet's atmosphere layer by layer. This will allow them to test whether oceans, clouds, storms, or even unexpected elements are hiding within its skies. The ultimate ambition is breathtaking: to identify biosignatures. These are chemicals that may not simply exist by chance but could be produced by living organisms. The confirmation of even one reliable biosignature would forever change humanity's place in the cosmos. But the James Webb Space Telescope's reach goes far beyond the study of a single planet. Its gaze has stretched across billions of light years, peering into the universe's earliest epochs. Recently, JWST made a discovery that left cosmologists stunned. In a galaxy that formed when the universe was just a fraction of its current age, scientists detected complex organic molecules. These were not simple atoms like hydrogen or helium. They were large, intricate compounds known as aromatic hydrocarbons. On Earth, these molecules are familiar to us. They are found in coal, petroleum, burning wood, and even the haze of city air pollution. Yet finding them in a galaxy born nearly 13 billion years ago was beyond anyone's expectations. This meant that within just 1.5 billion years after the Big Bang, the universe had already advanced far enough to build complex chemistry. It challenges our assumptions about how quickly galaxies could form and enrich themselves with heavy elements. The galaxy where these molecules were found, SP4-1847, adds even more mystery. Although extremely young by cosmic standards, this galaxy had already grown to a mass comparable to the Milky Way. It was producing carbon and oxygen at levels similar to those seen in much older galaxies. This rapid growth suggests that the universe may have been creating the building blocks of life far earlier than scientists ever believed possible. If complex chemistry was widespread so soon after the birth of the cosmos, then the potential for habitable environments might also have been widespread. This raises haunting questions. Could worlds capable of supporting life have existed billions of years before Earth was even formed? If so, could civilizations older than ours have once looked out at their skies and wondered the same questions we ask today? Every discovery made by JWST pushes us closer to answering humanity's deepest mysteries. Are we alone in the universe, or is life a common thread woven throughout the stars? Where did the very first spark of life originate, on Earth, or somewhere far older and more distant? And ultimately, what fate awaits the universe that gave rise to us? The James Webb Space Telescope is more than just a machine orbiting in space. It is a time machine, reaching back billions of years to show us the earliest stages of creation. It is a mirror, reflecting not only the structure of the cosmos but also our endless curiosity as a species. And it is a guide, pointing us toward discoveries that will shape philosophy, science, and human destiny for centuries to come. By exploring ancient galaxies, studying the birth of stars, and uncovering the secrets of alien worlds, JWST is rewriting the story of existence itself. It is inspiring dreamers, thinkers, and explorers across the globe to look upward and imagine what might be waiting in the darkness. And as its journey continues, one truth becomes clear. We have only begun to scratch the surface of what the universe is willing to reveal. The next great revelation may arrive tomorrow, or it may already be hidden in the data we are only beginning to analyze. One thing is certain: the James Webb Space Telescope is not just answering questions. It is creating entirely new ones.